Alright, this video is dedicated to the first exam review. We covered the following topics so far. We started by discussing LP modeling. So for this part, you need to know how to formulate a linear program. You need to know what are the implicit assumptions made by a linear programming model. And you are expected to know how to formulate the model in EMPL and solve it using one of the solvers provided with the EMPL distribution, as well as Excel solver. In formulating a linear program, I want you to follow the recommendations that you got in the first homework. You need to clearly specify the indices you are using, the decision variables, the constraints. You need to indicate whether the variable is non-negative or unrestricted in sign, and so on. So the second topic that we covered was graphical solution of two-variable LPs. For this part, you essentially need to know how to solve small-scale LPs graphically. You need to clearly specify the feasible region. You need to understand what the isoprofit or isocost line is and how we use this to find the optimal solution to the problem. You need to be able to distinguish between the different types of LPs, whether the problem is infeasible, optimal, or unbounded. When the LP is optimal, does it have a unique optimal solution or infinitely many optimal solutions, and so on. And this was covered by your second homework. So this was essentially the homework 1 material. This is homework 2. And the last part covered by the exam has to do with the simplex method. So here you start by converting the problem to the standard form. And then you have the dictionary versus the Tableau representation. So you need to know what the motivation is for the simplex steps, how we select the entering variable and why, how we select the leaving variable and why, what the basic feasible solution is and what's the difference between a basic feasible solution and just a feasible solution. Then what kind of issues we can have with the iteration. So if we cannot select the entering variable, then this means that we reach the optimality, right? So you need to know why we have the optimality criterion in the simplex method the way we have it. Then what happens if we cannot select the leaving variable? This means that the ratio test fails, and then when the ratio test fails, you actually have an unbounded problem. So you need to know that when you perform the simplex iteration, and if, for example, you will obtain at some point a basic feasible solution where one of the basic variables is negative for some reason, then this means that there was an issue with the ratio test and you need to go back and recheck how you've done the ratio test. So usually having a negative value in the right hand side is an indicator that you messed up with the ratio test somewhere. And when we grade the steps of the simplex method, if we see that, let's say you got a negative value in the right hand side and then you just didn't pay attention and proceeded with the iteration, then we don't count it as just a numerical mistake. So this is a conceptual mistake because, we don't penalize for the numerical mistakes as much as for conceptual mistakes. But at the same time, sometimes the numerical mistakes also help us spot the conceptual mistakes that you make, and this is one of the examples. So then, of course, the issues with initialization lead us to a couple of methods of how we can deal with it. So we had the two-phase simplex and the big M method, and this is covered by the third homework. Alright, so this is a very brief summary of what we have done so far. I'm also posting a couple of new videos that discuss how you find alternative optimal solutions using the simplex method, and also how we apply the simplex method to the general LPs that involve unrestricted and signed variables in addition to the non-negative variables. This material is actually covered in the homework number 3, but I wanted to go over this in more detail. So then the second video also has a discussion of the fundamental theorem of linear programming. This is something that you already kind of know at the intuitive level, but I wanted to explain how this can be established using the simplex algorithm by analyzing the phases of the two-phase simplex method. And also the second video concludes with a discussion of the complexity issues. Again, it's related to homework number 3. In the homework you had this Clemente example, and the video explains why we had that example in the homework. Essentially, it talks about how simplex method can be inefficient in some problems which are specifically constructed to illustrate this point. Alright, the best way to prepare for the exam is to go over all the lecture slides, review the lecture notes, definitely make sure that you know how to do all the homework problems, you know the answers to all the lecture quiz questions, and definitely review the sample exam, and also use the practice exam that I posted to practice. You have unlimited attempts for this one, but the real exam will be 90 minutes long, so keep in mind that you will have a limited time. So when you are done practicing, I advise you to try to take the practice exam once again and time yourself to make sure that you can do it within the allocated time. Next, we'll quickly go over the sample exam. This is one of the tests that we had in the past. Under normal circumstances, this would be a closed book, closed notes exam, and I would normally allow to use a one-page formula sheet. And actually the main objective of this exercise was to help you summarize all the information that you learned from the course so far in a limited space. So this kind of helps you think critically and decide what is more important, and this really helps you prepare for the exam. Even though this time it will be open book, open notes, I still recommend you to go over this exercise, essentially, go over all the material and try to prepare a one-page formula sheet that you could use during the exam, so that you don't have to look for things as you work on the problems, because remember, you will have limited time, and actually this exercise really helps you to summarize things. So other than the exam being open book, open notes, other rules pretty much apply to our test as well. Make sure that you present your solutions clearly, and you will have to submit your handwritten work together with the exam, just like you do it with the homework. So I'll ask you to scan and attach your solutions in order to be able to review your work and give you partial credit where it's due, or the other way around. Sometimes you may guess the answer correctly, but from your work we can see that you are not on the right track. So essentially, the grade that you're gonna get on eCampus is just an estimate of the actual grade that you'll get for the exam. So it can go either up or down as a result of us reviewing the materials that you submit. So, and the type of problems that you'll get for the real test will be similar to what you have in this sample exam. So there are a couple of formulation problems. In our case, you'll actually be asked to formulate these LPs in Ample and solve them and report the answers in addition to formulating the model. And then you will need to submit a screenshot of the work you've done in Ample. So you should be very comfortable with the Ample models that we discussed so far. And in particular, in the second homework, you were asked to implement a general linear program in Ample. So that code will pretty much work for any small model that you will have. But then we also developed a couple of specialized models. If the problem is of that type, then you should use some of these specialized models. So for example, we had the inventory model, the diet problem, and so on. So if the problem from the test is of that type, then you should modify one of these codes that you have in order to solve it in Ample. So, but make sure that all your ample codes are running and you can use them during the test. So then the remaining problems would be the graphical solution of the LP. You need to understand also the steps of the simplex method graphically. And when you have a two-variable LP, and even if you're asked to solve it, let's say using the simplex method rather than graphically, you should take advantage of the fact that you can also solve it graphically and verify your answer by solving it graphically. So it always helps you to be confident that you've done the computations correctly. So then the next two problems would be on the simplex method. So here we have an example with the two-phase simplex method and the big M method. And this is similar to what you should expect for the real exam. So you'll be asked to submit all your answers on eCampus, but still you are recommended to do everything on paper. And when you solve the problems on paper, treat this exam as a paper-based exam, because you'll have to scan and attach your solutions together with your submission. So please write things clearly and carefully. I'm sure you don't want us to spend extra time trying to figure out where you wrote things and why you wrote them, right? So make sure that you present things clearly and, make sure that you sleep well, eat well before the exam, and are in a good physical and mental shape when you take the test. And, assuming that you do your homework, I'm sure you will do great. I like to call the exams the celebration of knowledge, because this is what it is about. We are celebrating what you learned so far, so let's celebrate it in style.
Cheers to the celebration of knowledge.